Here's an example. We have the square root of 5 times the cube root of 25. And the instructions, which are very important to read, says to use rational exponents to simplify. Okay, so they want us to convert these to fractional exponents and then see what we can do with it. Okay, so this is equal to, the square root of 5 is the same as 5 to the 1/2 power, and the cube root of 5 is the same as 25 to the 1/3 power. Oops, 1/3 power. Okay, well I can't multiply them together using rules of exponents until I have the same base. I have base 5 for the first factor and I have base 25 for the next. So let me rewrite this. I'll leave the 5 to the 1/2 power alone, but I can rewrite 25 in here. 25 to the 1/3 power. I can rewrite 25 as 5 to the 2nd power. So it looks like if I bring down 5 to the 1/2 power times, this guy has 5 to the 2nd raised to the 1/3. So the rules of exponents say that's 5 to the 2 times 1/3. That's the rules of exponents. It says if you have a power raised to a power, you multiply them together. So this is 5 to the 1/2 power times 5 to the top times top over bottom times bottom, 2 times 1 over 1 times 3. Okay, great. Now I'm multiplying the same base. So I'll just remind you that right here I use the rule that says a raised to the m power and then raise that to the n power. That's equal to a raised to the m times n power. That's the rule of exponents that I use there. And then right here I'm about to use a rule of exponents. It says a raised to the m power times the same base a raised to the n power is equal to a raised to the m plus n power. So that makes this 5 raised to the 1/2 power plus 2/3 power. Well, I need to add those exponents together, and I make a little note to myself that the least common denominator of 1/2 and 2/3 is just 2 times 3, which is 6. So I'm going to rewrite these fractions so they have 6 on the bottom. That's equal to 5 raised to the, let's see, to get 6 on the bottom, I multiply 1/2 top and bottom by 3. I get 3 6, plus, to get 6 on the bottoms for 2/3, I multiply top and bottom by 2, 4 6. Okay, now I can go ahead and add the exponents together. 3 plus 4 makes 7 6. Okay, and then I would like to walk away from this problem and say I'm finished with it, but since the original question did not have fractional exponents, instead the original question had radicals, we are behooved to write our answer in radical form if possible. And in this case it is possible. What I'm going to use on this step is a raised to the 1 over n power is equal to the nth root of a. I'm going to actually use it with a little modification, and that is I don't have the 1 over n power for 5 to the 7 6, so I'm going to rewrite 5 to the 7 6 as 5 to the 1 6 and then raise that to the 7th. And that actually uses the first rule that we saw up at the top here in the cloud, because that rule says that if you have a power raised to a power, you multiply the powers together. So 1 6 raised to the 7th, 5 to the 1 6 raised to the 7th is 5 to the 1 6 times 7, which is 7 6. So that's a true equality there. And now the next thing I do is inside the brackets, I rewrite the 1 6 power as the, I think I might have written it wrong, because I'm going to end up with this. Well, it'll work. This is the 6th root of 5 raised to the nth power, 7th power. So that's one way of doing it. But there is another way of doing it, and that would be if I had done this instead. What if I had said this is equal to 5 to the 7th, and then a bracket, and then raise it to the 1/6. Then this would be equal to the 6th root of 5 to the 7th power. And you know what? I have two answers, but they're both the same answer. Now they're the same because, let's see, they are the same because, let's write it this way, the nth root of a to the m is the same as the nth root of a raised to the m.